Hello friends, welcome in YouTube channel. I am Samin Sheikh, working as an assistant professor at KV Naik College, Nasik. In the last video, I will already focus on the protection of OS group by using simple ether strategy. In this video, I will focus on the OS protection of OS group by another way. The first, the formation of alkoxy ether such as MEM, BOM. The MEM means methoxy-methyl ether. The methoxy-methyl ether it can be obtained by simple methoxy-methyl chloride in basic condition, and the protection can be done in Lewis acidic condition. MEM means methoxy-ethoxy-methyl ether. It can be obtained by using methoxy-ethoxy-methyl chloride in basic condition, and the protection can be done similar like MEM in the Lewis acidic condition. BOM means benzoxy methyl ether. It can be obtained by using benzoxy methyl chloride in the basic condition. The MEM and MEM are stable in basic and mild acidic condition, but BOM is stable in basic as well as acidic condition. In this reaction, there are three types of OS protected. Then by using reducing agent, then the protection can be take place only BOM ether, not the MEM and MEM. But in Lewis acidic condition, the protection will be take place on MEM ether and MEM ether, not the BOM ether. Now, the OS is also protected by using serine reagent such as trimethylserine, triethylserine, triisopropylserine, TBDMS TBDPS. The structure of this reagent like this. The steric page increases from left to right. Now the protection can be done in strong acidic condition or F- source, generally KF or N-butyl ammonium fluoride. It is the bulky group TBDMS ether are more stable than less bulky. The selectivity for protection of the primary alcohol at the same order due to steric effect. Therefore, primary alcohol is protected by using bulky reagent due to steric effect. Now, the OS attack on serine to remove the leaving group such as Cl and triphthalate in basic condition, generally pyridine, dimethylamino-pyridine or 2,6-rutidine imidazole used as a base for this purpose. The dimethyl triphthalate is the most useful for the protection of secondary alcohol preferentially as compared to the other alcohol. Now, in this reaction, the methylchlorobenzoic acid attack on the alkene from the same site of OS group due to hydrogen bonding to form the beta epoxide. But how to obtain the alpha epoxide? This can be done. The first OS is protected by using bulky reagent T-butyl-dimethyl chloride. Then methylchlorobenzoic acid approach from the less hinder side, that is alpha side, to use alpha epoxide, and the protection can be done by using F- source such as T-butyl ammonium fluoride to use alpha epoxide as a product. Now, how to oxidize the secondary alcohol in presence of primary alcohol? This can be done by protection. The first, the OS primary OS is protected by bulky reagent. Then oxidize the secondary OS by using pyridine chlorochromate. Then the protection can be done by using F- source and to use the target molecules. Now, in this reactant, there are two types of OS group is protected. One is protected by using T-butyl-dimethylserine, and all is protected by using T-butyl-diphenylserine. It is a more bulky as compared to this serine. Therefore, in presence of acetic acid, the first deprotection is take place from less bulky side, that is this side. Now the alcohol is also protected by formation of acetate by using TSP, tetrahydropyran ether. In this case, the OH group is converted into acetal in acidic condition. It is a reversible reaction. It is stable into the basic condition. Now deprotection can be take place in again same acidic condition. Now it is not useful for optically active compound, because if by using TSP, then formation of the stereogenic center at this carbon. Therefore, the reaction take place through diastereomeric phase. We know that the physical and chemical property of diastereomers are different. Hence, the yield of the product is lost after completion of the reaction after the protection. In this reaction, there are two types of OH. By using acid, then the protection takes place on OTSP, not the O silane. Similarly, in the next reaction, two types of OH is protected. One is protected by MEM, or is protected by TSP. In acid condition, the deprotection will take place on TSP ether, not the MEM ether. Now, OH is also protected by converting into ester group such as acetyl chloride, anhydride, and pyroxide. The general reaction, alcohol converted into ester. By formation of ester, it is more stable in acidic and mild basic condition, not compatible with strong nucleophile such as organometallic reagent, because it is easily attack on the ester group. Now, the protection is take place by using acetic anhydride or acetyl chloride, and the protection can be done by using basic condition. The structure of the pyroxide means the T-butyl acetyl chloride react with alcohol to form the pyroxide. Then the protection can be done by using mild base. Now, already completed the protection of OH group by using simple ether, alkoxy ether, Silyl ether, acetal, and ester. In case of simple ether and alkoxy ether, the protection is stable in basic condition and by mild acidic condition. But in case of bomb, the stable acidic as well as basic condition. The Silyl ether is stable in acidic and basic condition. Acetal is stable mostly in basic condition. Some ester is also stable in the basic condition. Now we have discussed the chemo-selectivity of the OH group. If reactant containing number of OH group, at that time which OH group is firstly protected? This can be done by following rules. The primary alcohol having less steric effect, so it can be easily protected as compared to secondary alcohol. Similarly, equatorial OH also having less steric effect as compared to axial OH. Hence, equatorial OH is protected or deprotected firstly than the axial OH. Now, equatorial OH with vicinal axial OH or OR, it is more preferably protected or deprotected as compared to another equatorial OH without vicinal axial OH or OR group is present. In this compound, there are different types of OH group is present. One is present at equatorial position. The carbon number 3 OH present at the equatorial position. Carbon number 4 OH present at the equatorial position. Carbon number 5 OH present at the equatorial position, but it is primary alcohol. Therefore, first, which OH is protected? It is simple. The primary OH is firstly protected or deprotected. Then, equatorial OH. All these three are the equatorial OH. Then, those equatorial is first protected with having axial OMA or OH group. Therefore, second carbon OH is protected as compared to 3 carbon OS and 4 carbon OS. Therefore, protecting or the protecting order is 6 OS firstly protected and second OS firstly protected and third OS then and similar like 4 OS. Now, considering this reaction, there are two types of OS group, alpine equatorial position. The protection can be done by using benzyl bromide. Therefore, OS attack on the benzyl bromine is removed and protection is HO. But which OS is protected out of these two? This OS having axial OME and this OS not having any types of axial OME. Therefore, firstly, this equatorial OS is protected according to this rule and use like this product. Now, in the next lecture, I will focus on the protection of 1,2 and 1,3 diol. Also focus on the protection of aldehyde and keto group. Thank you so much and take care.